of 9.3. Okay, so yesterday we stopped with talking about geometric sequencing, right? Where you find whatever term you're plugging in, you do the first term times the rate minus the number, and you solve from there. Now we're going to talk about finding a term of geometric sequencing. So what happens if it says, find the 15th term of the sequence whose first term is 20 and whose common ratio is 1.05. So the ratio equals 1.05. We want the 15th term, and term 1 equals 20. How would I plug that in to solve from there? What would you need to do?
Well, you plug the R in where it says
Beautiful.
R.
Yes. And then what goes into the N? What term are we trying to find?
The 20.
The 15th. 15 equals, what's my first term? 20. And then I multiply it by my rate of 1.05 to the 15 minus 1.
Wait, so the A1 is the 1?
Yeah, your first term is your A1.
Gotcha.
Okay. They're the same thing. Okay. So 15th term, I would set it up that way. I would do 1.05 to the 14th power, and then I would multiply it by 20, and then you should get an answer of, if we round to one decimal place, 39.6 is your 15th term. So you're going to have to plug it in and solve from there when they ask for what term they want, okay? Now, what happens if they give us something where they say, find a formula for the nth term? Okay, we want a formula for the nth term. When the sequence goes 5, 15, 45. It's a geometric sequence. Five, 15, and 45. How can I figure out the nth term of this sequence? How can I solve this? What do you need to do to solve this?
5, 15, or 15 over 5.
Okay, put the 15 over 5. Good. Why are you doing 15 over 5?
Because that's what you have.
Because that tells you your what of this equation over here?
Your ratio.
Yeah, your rate, your ratio. Good. So what's 15 over 5? 3. Is 45 over 15 the same?
Yeah.
Okay. So then I have the 3, the ratio. Do I have the first term?
Yeah.
What is my first term? 5. So right now I have an equation that looks like this. 5 times 3 to the n minus 1, yeah? Okay. Now, from there, what is the nth term of the sequence? So the common ratio is 3. That's my equation. So that's as far as I can take it. That's the equation for this nth term. Now, if they told us solve for the 9th term, what would I do?
You plug it, the 9 in to the n.
The 9 in for the n. So I have this, and 9 minus 1 is 8. So I have 3 to the 8th times 5, 3 to the 8th times 5, and you would get 32,805 for your 9th term. Okay, so that's a way to work it, to find the equation, and then from there we can plug it back in to find any term that we would like. Okay, let's find a term of a geometric sequence again. Let's try this. It says the 4th term of a geometric sequence is 125. Okay, fourth term or A of 4 equals 125. Okay, and then it says the 10th term is 125 divided by 64. And it wants us to find the 14th term. How can I go about that? How can I figure?
Just one less than the 15th term.
Can we just change the 10?
Well, we can relate the 10th term and the 4th term to each other. How could we relate them?
They add together.
They don't add together.
Yeah, sure, you have to tell me what you're talking
You divide them. You divide them by 2.
If I have the
Come on,
10th
guys, help me.
term and I set it equal to,
about.
okay, if I set it equal to the 4th term times what? What would be times my rate or my ratio? But what is the power of that ratio? What's the difference between the 10th and 4th term?
6.
6. So my ratio power becomes 6. So that I can relate these to each other. Okay? So if I have A of 10, my 10th term equals my 4th term times my ratio to the 6th power. From there, I can solve for my ratio so that I can then create an equation. So my 10th term is 125 over 64. My 4th term is 125. My r to the 6th. How do you solve from here to get r by itself? What do I need to do? Divide by 125. When I divide by 125, okay, I get r to the 6th equals the 125, or the 125s cancel out, yes? Giving me 1 over 64. Well, because you flip and multiply, Parker, to have this, and those cancel. Okay, give me 1 over 64. So 1 over 64 equals r to the 6th. What do I have to do from there to get r by itself to find the rate, the ratio? How do you get rid of a power? Not the square. What power is this? The 6th root. 6th root. 6th root. What's the 6th root of 1? What's the 6th root of 1? 1. What's the 6th root of 64? 64 breaks down into 8 and 8, right? And 8s break down into 4 and 2.
So it's 2.
So it's 2 because 4 is 2 and 2, right?
Yeah.
So I have
1
1, 2, 3, 4, 5, 6. So it's 1 over 2. So this is my r. Okay? From there, I can now create an equation, okay, to find the 14th term. Because the 14th term can relate to the 10th term. Okay? And you always put the largest term on the one side of the equal sign. So a to the 4 of the 14th term equals a of the 10th term times my ratio, which we now know is, or my rate, which is now 1/2. But what power is that to? How do 10 and 14 relate? 4. So my power is 4. So I plug this in and I say a of 14 equals, plug in the 10th term to where the 10th term is, 125 over 64 times 1/2 to the 4th. What is 1/2 to the 4th? What is 1 to the 4th? 1. What's 2 to the 4th?
No.
2 to the 4th is not 4. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is?
Oh, it's 16.
It is 16. Lindsay is right. Now, that means that I get a of 14 equals 125 over whatever 64 times 16 is. 1024. Okay, over 1024. Does that reduce to anything for me? I don't think so. So this is my 14th term. So when you have two terms, and it's not the first term, you have to relate them to each other by creating equations that set the largest term equal to the smaller term times your rate to the difference between the powers. From there, you get your rate. Then you plug it back in to find your third term. You have to do it in that order. So this takes some time, but it's not super hard. It just takes time. So that's what we're looking at doing today a little bit. Now, let's talk about finding the sum of some things. The sum of finite geometric sequencing.
A's last year.
Yes. Okay.
Screw you. Why would you do that? He needs to start taking gas.
Stop talking. Okay, finite geometric sequences. There is a formula that we're going to use that has a common ratio that's not equal to 1. And it says this. S of n, meaning the sum of the numbers, the sum, okay, equals n. We're going to break it down and talk about all the parts.
What was
I
that?
don't even know.
No.
Greek letters for E.
It is Greek.
I don't wanna do that.
Okay.
No, no thank you.
Is there
Now-
a way we can go around it
This
in the lesson?
Erase that big letter.
I
A1
didn't like these last year.
equals
It looks like a
1 minus r to the n power, okay? Well, let's do it this way. So this can also be set equal to A1 times 1 minus r to the n power over 1 minus my ratio, okay? So this is how we're going to set it up. It says find the following sum. And it gives us 12. It gives us n equals 1. And it gives us 4 times 0.3 to the n. What's your question?
What is that called? The Greek letter.
Sigma.
Sigma.
I didn't like these last year.
You didn't like these last year? Okay, so now we want to find the following sum. What power are we going to?
I don't know, what the heck?
The 12, because 12 is on top. This is the sum we're looking for. After 12 units, how much does it all add up to?
Is that like the equal sign? That like,
Oh, so just circle over.
Okay, so 12 is what we're looking for. No, it's not an equal sign up here. Okay, so here's the deal. This is what we want to do, because if we don't do it this way, it's going to take us a long time. What we could do is we could all go 4.03 to the first, plus 4 times 0.3 to the second, plus 4 times 0.3 to the third. But that could take a while, especially if this number is like 125. Okay? So we're going to cheat, and we're going to use this part of the equation so that we can come up with it quicker. Okay? Your first term. What is your first term on here?
12.
Or what?
There's a 1.
Look, where is A1 in this?
Oh, it's 4.
It's 4. It's actually, okay, so 4 is my A1. My rate is 0.3 and n power, right? Okay, so we're going to take this, but my A1 is technically, we're not going to separate that 0.3 from it. We're going to take it and we're going to create it like this to say 4 times 0.3 and then parentheses, okay, or in this case brackets because we already have parentheses, 1 minus, what's your rate again, or your ratio? 0.3 to the 12th power, because that's my n in this case. I'm looking for 12, that's the number I'm looking for, over 1 minus 0.3. So I just plug those numbers in. So if you know what these numbers stand for, you literally just plug it into this equation here. Okay? So now I want to do what's here first so that I can multiply it by what's on the outside next. What is 0.3 to the 12th power? Because I need to do 1 minus 0.3 to the 12th. 1 minus point. And there's 2, 4, 6 zeros, and then a 5, 3, 1. 3, 4, 5, 6, 5, 3, 1. So you're going to get a crazy 0.9999949 on top. And then it's 1 minus 0.03. So I'm going to do 0.99. There's 2, 4, 6 nines. And then a 469 divided by 0.97. And I'm going to end up having 4 times 0.03 times 1 point, and it's a very long decimal. So I'll just round to there for now. And you should get an answer that is similar to 1.71, something around 1.71.
So we don't even really need the sigma.
The sigma tells me what to plug in here.
Yeah.
Yes.
Well, you still just need it.
Yeah, you're not plugging a sigma into your calculator, no. Is that what you're asking me?
No, I was just wondering if we needed it other than for the setup.
No, it just tells me what I'm doing. So then I get an answer of like 1.71, and that's the sum of all of those 12 terms added together. So it makes it easier than solving it 12 times and adding them together. Okay? So that's a finite. Then there is infinite geometric systems, and then we're done. So finite is that equation. Infinite.
I yet? Do we not use the, or I equals 1?
I and N are interchangeable. They're the same thing.
Okay.
They're the same thing.
So, am I saying it right? Sigma?
Yeah.
Okay.
Okay. Infinite geometric sequences has a different formula to it. And it looks like this. It says the sum equals sigma is infinity, I equals 0 in this case, A1 times my ratio to the I, where this equals A1 over 1 minus my ratio. So, if they give us an equation that says find each sum, and they give us an infinite series, and I know it's infinite because there's an infinity on top. Okay, how can I set that up and solve? This one's much simpler. How can I set that up and solve? Where is my A1? What is my A1? 4, because I want to use this equation here to cheat off of. So 4, what's my rate? 0.06. So 4 over 1 minus 0.6. Okay. 1 minus 0.6 gives me 0.4. 4 divided by 0.4 gives me 10. There's my answer. Okay. And the only reason I have that, yeah, it just makes it simple because my N was 0. So that is what we are working on tonight.